Now we will discuss about the classical problem of process synchronization, that is producer consumer problem. Okay, and here we will see how sleep and wake system call will help to eliminate busy waiting problem. Okay, so let's start with producer consumer problem. Here you see I have written the codes. This one here you can see void producer. So here producer will execute this code, and here you see I have written void consumer. So here consumer will execute this code. So here basically what will happen, a buffer will be there. Okay, a buffer will be there which will be empty initially, which will be empty. So producer will produce some item. So those items will be kept in a buffer. Okay, so it means what, if producer will produce the item, then the number of items in the buffer will get increased. And what consumer will do, consumer will consume the item from the buffer. So basically what consumer will do, consumer will decrease the item from the buffer by consuming. Okay, so actually here you see what will happen. I tell you, I think it's visible. Okay, yes. So here you see there will be a buffer. Okay, so here there will be a producer, and here there will be a consumer. So in a buffer there will be some empty slots. Okay, so producer what will do, producer will produce some items. Okay, so that the buffer will get filled like this. So it is an item, again producer will produce some item, again producer will produce some item. So producer will keep on producing, and what consumer will do, consumer will consume the item one by one. Suppose consumer has consumed this item, so now the number of empty slots get increased, or number of items in the buffer gets decreased. Now consumer will consume this item. So you can see after consuming the item, the empty slots are getting increased. Okay, so it's better to analyze the code. Okay, so here you can see what I have written, hash define n100. Hash define n100, it means what? It is the size of the buffer. Size of the buffer, the number of empty slots which are present in the buffer. For example, you just think there are 100 empty slots in the buffer. Okay, so 1, 2, 3, 4 up to 100 empty slots are there in the buffer. Hash define count equal to 0. Count is a variable. It means it counts the number of items which are present inside the buffer. For example, if the producer has produced 2 items, then the count will be 2. If the producer has produced 3 items, then the count will be 3. If the producer has not yet produced any item, then the count will be 0. Okay, so let's start with the producer. Okay, so now producer will produce the item. So you see what will happen, int item. Okay, so item means what? It is the item which is produced by the buffer. While true, while true means what? Here while true means the producer will keep on producing till the buffer is empty. The producer will keep on producing. Okay, so here you see what buffer is doing, int item is equal to produce item. So produce item is a function. Produce item is a function. So it is irrelevant to discuss about this function. You just, for the time being, you just understand that produce item is a function which is called by the producer. After calling this function, one item will get produced, and that item will be kept inside the buffer. Okay, like this. Suppose if producer wants to produce one item, so producer will call this item produce item. So what this function will do, this function will produce one item for one item, and that item will be kept in the buffer. Okay, in this way. So now here you see count is equal to 1 because one item is kept in the buffer. Okay, so this produce item will produce the item, and now you see this is a condition. If count equal to n, sleep. Here it means what? Count equal to n means what? N is the size of the buffer 100. Okay, So if the number of items in the buffer is equal to the size of the buffer, it means what? The buffer is full. Here you see, suppose if the producer will produce all the items, okay, here you see all the items. Now you can see empty slots are not there. So the size of the buffer is n, and n is equal to 100. Okay, and here you see, since all the items, since the buffer is full, it means what? Count is also 100. Okay, because count keep tracks of the number of items, so count is also equal to 100. So since the buffer is completely full, it means what? Now producer can't produce any more item. Even if producer wants to produce, where it will keep the item? So if the buffer is completely full, then producer can't do anything. Producer will go and sleep. Okay, so here you can see the busy waiting problem has been eliminated here. You see how? Here, if the buffer is full, then producer will sleep. So rather than continuously waiting to get the empty buffer, rather than continuously waiting to get the empty slot inside the buffer, here buffer will go to sleep. Buffer will not wait for the situation that when the buffer will be empty. No. Here when the buffer is full, so rather than continuously waiting for the empty buffer, producer will go to sleep. Okay. So here you see how this sleep system call has eliminated the busy waiting problem. Okay. In busy waiting problem, generally what happens? In busy waiting problem, the producer will keep on waiting when the buffer will be empty, when the buffer will be empty. Okay, so so doing this, producer will unnecessarily waste the CPU cycle. So here we have used a sleep system call. Rather than wasting the CPU cycle, you just go and sleep. Fine. So now here is, you see, insert item. So it means what? Suppose if the buffer is not empty, suppose if some spaces are left in the buffer, some empty spaces are left in the buffer. Okay. Suppose if the buffer is not full and some empty spaces are left in the buffer. So now producer can produce and insert the item. Here you see 1, 2, 3, 4, 5. 5 empty slots are there. So now producer can insert some items like this. Fine. And here you see what I have written. If count equal to 1, wake consumer. So just try to understand this statement. This is a very important statement. Just understand it very carefully. Try to listen it. If count equal to 1, wake consumer. It means what? If count is 1, if only one item is present in the buffer, suppose. If only one item is present in the buffer, so consumer can consume this item. Okay. So that's why in order to consume this item, producer is waking up the consumer. Okay. Because even if one item is present in the buffer, consumer can consume it. No problem is there. So for that, producer is waking the consumer. But why producer is waking the consumer? Because waking means what? If someone is sleeping, then you will wake him up. Okay, it definitely means that here the consumer was definitely sleeping. That's why producer is waking the consumer. Because you see, if count equal to 1, it means what? Before count equal to 1, before count equal to 1, okay, before count equal to 1, only, yes, definitely the count was 0. It's a common sense, you see, before count equal to 1, definitely the count was 0. Okay, so if the count was 0, then consumer has nothing to consume. Consumer will not consume anything. What consumer will consume from the empty buffer? Buffer is empty. Count is 0 means what? Buffer is empty, so consumer can't consume anything. So the consumer was sleeping. Okay. So the consumer was sleeping when count was 0. Here you can see, if count is equal to 0, consumer sleep. So consumer was sleeping when count is equal to 0. So when producer has produced one item, so this item has to be consumed by the consumer. So for that, the producer is waking the consumer. I have produced one item in the buffer. You just wake up and you can consume it if you want. Okay. That's why here I have written if count equal to 1, wake consumer. Okay. So that's all about producer. So let's discuss about consumer. So what will happen now? You see here, void consumer int item while true. It means what? Consumer will keep on consuming. Okay. Even if one item is present in the buffer, then consumer will consume it. So here you see, if count equal to 0, sleep. So that's what I told you right now. If the buffer is empty, then consumer has nothing to consume. So what consumer will do? Consumer will sleep. So rather than waiting for some items to be inserted in the buffer, it's better for the consumer that consumer should go and sleep. So here you can see the busy waiting problem is getting eliminated. Here consumer is not unnecessarily waiting for the buffer to get filled. Okay. If the consumer will do so, then again the same problem. The CPU cycles will be wasted. So it's better that consumer should go and sleep if the buffer is empty. Okay. So that's what happening here. So in the next line, item is equal to remove item. Item is equal to remove item means what? Suppose if count is not 0, suppose if count is suppose 3. Okay. So 3 items are there in the buffer. So now item is equal to remove item. So now consumer can consume some item, or you can say that item is equal to consume item. So if some items are present in the buffer, then consumer will consume it. Maybe here consumer will consume one item. So consumer has consumed this item. So now the count has become 2. Okay, in this way. So that's what is happening here. You see, if count is equal to remove out item, after I have written count is equal to count minus 1. Because how the consumer will remove the item? By consuming it, by decrementing it. Initially the count was 3. So now after that 3 minus 1 is equal to 2. So this time the count is 2. Fine. And after that, here you see, if count equal to n minus 1. Fine. If count is equal to n minus 1, wake producer. Here count is equal to n minus 1 means what? Suppose you see, suppose the number of slots in the buffer is 100. Okay. And if count is equal to 99. Okay. How count is equal to 99? Because here you see I have written n minus 1. So 100 minus 1 is 99. So suppose if count is equal to 99, so definitely here you can see one empty slot is there. So one empty slot is there, it means what? So this empty slot can be filled by the producer. So in order to fill by the producer must be waken. Okay. So that's why here I have written if count equal to n minus 1, wake the producer. So that producer will come and fill this empty slot. Okay. And also one thing is there, wake means what? If somebody is sleeping, then I should wake him. So it means what? Before count equal to n minus 1, it means what? Before this, what was the value of the count? Before n minus 1, what was the value of the count? Definitely the count was 100. Okay. Before n minus 1, definitely the count was n. So when the count was n, okay, it means what? The buffer was completely full. So the buffer was completely full. So if the buffer is completely full, so producer has nothing to produce. Okay. So if producer has nothing to produce, then what can producer do? Producer will wait for the empty slot. Okay. So rather than waiting, producer should sleep. So the consumer is waking the producer. Okay, I have consumed one item. There is one empty slot in the buffer. Now you just please you wake up and you can produce one more item. Okay, that's why I have written here wake producer. Okay. Now here you can see basically what is happening. Producer is incrementing and the consumer is decrementing. Okay. So here you see till now everything has worked fine. Okay. But there will be some situation or I can say that there may be some serious problem that has to be avoided. You see when? Suppose you see here at this point, I draw here again. By mistake I have dropped it. Okay. Suppose at this point, if count equal to 0, it means what? If the buffer is completely empty, then consumer will sleep because consumer has nothing to consume. So just before executing this, so in order to sleep, what consumer will do? Consumer will execute this sleep system call. Okay. So just before executing this sleep system call, here at this point, the context switching happened. Suppose I tell you once again, when the count was 0, I mean the buffer was empty. So the consumer came to know about this, that the buffer is empty. So the consumer wants to sleep. So in order to sleep, the consumer must execute this sleep system call. If the consumer will not execute this sleep system call, then consumer will not sleep. So definitely consumer will have to execute this sleep system call in order to sleep. But before executing this sleep system call at this point, okay, at this point context switching happened and CPU is given to the producer. Then you see what will happen. So now you see, suppose producer is executing this line. Okay. Yeah. If count equal to 1, wake up the consumer. Okay. Suppose when the context switching happened and CPU is given to the producer, and suppose producer has count is equal to count plus 1. Producer has produced one item. Okay. Count is equal to count plus 1. So now producer want this item to be consumed by the consumer. Okay, so for this the producer must wake the consumer. Okay, because here you see when producer produced this item, okay, before that the buffer was completely empty. So when the buffer was completely empty, then producer was expecting the consumer to sleep. Okay, here you see the buffer is completely empty. So producer thinks that consumer is sleeping. Okay, so although the consumer is not sleeping here because consumer has not executed this sleep system call. Okay, because before executing the sleep system call, the context switching happened. But here the producer is thinking that consumer is sleeping. Okay, because the buffer is empty. So now after producing one item in the buffer, if count equal to n, it means what? If the buffer has one item, wake the consumer. So producer wants to wake the consumer so that the consumer will consume things. So for that, producer will invoke wake consumer system call. Okay. So here producer has invoked wake consumer system call, but the problem will be there. You see, now when the CPU is again given back to the consumer, okay, so definitely the consumer will start from this point. Okay, the consumer will start from this point. So if the consumer will start from this point, then definitely consumer will execute this sleep system call. Okay, so here you can see from producer side, producer is trying to wake the consumer by invoking the wake consumer system call, and from consumer side, consumer is invoking this sleep system call. So if consumer is invoking this sleep system call, then definitely consumer will sleep. So it means what? This wake system call got wasted. Okay. Because here consumer is completely unaware about this wake system call. Okay. And after that, consumer just executed this sleep system call and now consumer is sleeping. So in this way, this wake system call got wasted. So now suppose, so here consumer is sleeping. So now suppose again the context switching happened and the CPU is given to the producer. Fine, just wait. And the CPU is given to the producer. So now you see what will happen. Here after invoking the wake consumer system call, now producer is thinking that consumer has received this wake system call. So consumer is waking. But actually it's not true. Consumer is sleeping. So here with this false hope, consumer will keep on producing the item in the hope that consumer will consume this item. Okay. So producer is keep on producing the item. But actually consumer can't consume this item because consumer is sleeping and producer doesn't know about this. So he is continuously producing the item. Okay. So when after continuously producing the item, definitely the buffer will be full, the buffer will get filled up. So when the buffer will get filled up, so producer can't produce anything. So since the producer can't produce anything, so producer will invoke this sleep system call. Okay. So now producer will sleep. So producer will sleep in the hope that consumer will wake me up. Okay. But here how consumer will wake him up? Because consumer himself is sleeping. So here you see at this point, producer is also sleeping. Producer is also sleeping. So now you can see that both are sleeping. Both are sleeping in the hope that others will waking up. Here producer is expecting from the consumer that consumer will wake him up, and consumer is expecting that producer will wake him up. But here this will never happen because both are sleeping. So both can't be woken up. Okay. So it's a deadlock problem. Okay. So you see how actually this deadlock problem, what is the basic reason behind that? Because here you see the wake up system call from the producer got wasted. That's why this happened. So because even after the receiving the wake up system call, consumer was unaware about it. Okay, consumer was unaware about it and consumer executed this sleep function call. So that's the problem that happened. So it's basically like this. Suppose you want to sleep. Okay, it is a bedroom. Okay, and you want to sleep. So in order to sleep, you must enter into your bedroom. Suppose you are a consumer. Okay, so in order to sleep, you must enter in this room. But before you enter in this room, producer will come, another person who is a producer, he will come and he is thinking that you are already inside this room. So he wants to wake you up. So for that, he will knock at the door. Okay, he will knock here. And after that, he will go. He will go to somewhere else. But actually, you are outside the room. So after some time, when you will come, you will never know about this. You will never get to know that the other person, that producer, has made a knock. He tried to wake you up. Okay, because when he was knocking at the door, you were not present here. You were somewhere else. Now you came here. Okay, so now you never come to know about this knocking and you will enter inside the room and you will sleep. So despite getting a knock call from the producer, you are sleeping. So that's the problem. So how this problem can be solved? So here you see this problem can be solved. Just wait. This problem can be solved if rather than knocking the door, okay, rather than knocking the door, if producer comes and he hangs one tag at the knob of the door, okay, and in the tag it will be written wake. W means what? Wake. In the tag it will be written wake, okay, and after that if producer goes to somewhere else, so this tag will be used later by the consumer. So after finishing task, when consumer will come, he will check this tag, he will see this tag. So in the tag wake is written, it means what? Now consumer has come to know that somebody has tried to waking up, so he will not enter inside the room. Okay, so this is the so this is the solution, so that knock call should not be wasted. Okay, so here rather than directly invoking the wake system call to the consumer, the producer should set some bit. Okay, so now the semaphore concept comes. Okay, so what actually happens in semaphore? Semaphore actually it's a variable. It is an integer variable which was introduced by Dijkstra in 1965. So in this concept, what happens that here you see producer, here you see consumer. So rather than invoking the wake system call, okay, directly to the customer, here producer should should send this wake system call to a semaphore variable. I think it's not visible. Here you see I am writing. So here you see, rather than invoking a wake system call directly to the customer, okay, producer will send this wake system call to a variable, that is semaphore variable. So this semaphore variable is an integer, okay, it holds some integer value. Suppose the semaphore variable is 1. It means what? The producer has sent one wake system call at this semaphore variable. Okay, so now producer you see has not sent the wake system call directly to the customer, so here I am removing this. So rather than sending directly, producer had sent here. So now this semaphore variable can be used by the consumer later. How? After finishing some task, when consumer wants to sleep, so consumer will check. So before sleeping, maybe at this point, the consumer will check the status of this semaphore variable, and if the status of this semaphore variable is 1, then consumer will come to know that I have been asked not to sleep. It means what? I have to be woken up. I can't sleep now. Okay. So in this way, the wake system call will not be wasted. Okay. So in this way, semaphore works. So you see here here it's a case of one producer and one consumer. So in case of multiple processes, okay, in case of multiple processes, we use semaphore variable as an integer. Okay, so it will semaphore variable will hold some integers like 4. It means what? It means what? 4 wake up calls has been invoked. So for 4 processes, okay, process P1, process P2, process P3, process P4. So here what will happen? Here suppose all the 4 processes wants to sleep. So all these 4 processes before sleeping must check the status of the semaphore variable. Suppose process 1, so let it be 3, okay, for 3 processes. Suppose process 1 wants to sleep, so process 1 will check the status of the semaphore variable. After seeing process 1, so after seeing the status of the semaphore variable as 3, process 1 will understand that I will not have to sleep. Okay, I have been asked to wake up, so I will not sleep. Okay, so what process 1 will do? Process 1 will not sleep, and since process 1 has accessed this semaphore variable, so it will decrement it, and now the semaphore variable will become 2. Okay, so now after this, suppose process P2 wants to sleep. So before sleeping, process P2 will check this semaphore variable. Okay, so after seeing the value as 2, process P2 will understand that he has been asked not to sleep. So process P2 will not to sleep. So now process P2 will not sleep, and process P2 will decrement the value to 1, from 2 to 1. Now process P3 comes, process P3 wants to sleep. So process P3, before sleeping, process P3 will check the semaphore variable. Okay, so the semaphore variable is 1. So process P3 will understand that he has been asked not to sleep. So process P3 will not sleep, and process P3 will decrement the value to 0. Okay, now the semaphore variable is 0. It means what? All the wake up system calls have been utilized. Now there is no more wake up calls. Now you can sleep. So if the system call is 0, and suppose again process P1 wants to sleep, so before process P1 going to sleep, so before sleeping, process P1 will check the status of the semaphore variable. If it is 0, then process P1 will come to know that there is no more wake up call, so I can sleep now. Okay, so that's a little bit overview about the semaphore variable. Okay, so in the next video, in the next lecture, I will teach you about the semaphore variable. So I hope you got the how producer consumer works, and how this sleep and wake system call helps to avoid busy waiting problem. Okay, thank you.